last time we introduced complex numbers and we simplified radicals that had negatives underneath them. And then we also talked about adding and subtracting complex numbers. So today we're going to extend that to multiplying and dividing complex numbers. Now remember when we talked about adding and subtracting complex numbers, we said that we add them or subtract them just like what we do with polynomials, right? We treat the I like it's an x in a polynomial and just combine like terms. We're basically going to do the same thing when we multiply. We're going to multiply this out just like you would do for binomials. We would distribute to everything, right? So if we were to multiply this out, not even understanding what I represents, what would this multiply out to be? If you had the 2 plus 5i times 4 minus 3i, even if you didn't know what I means, if you were going to multiply this out like we've done before, what would you get? Not a trick question. What would we get? Minus 15i squared, right? Right? We would distribute it. We would FOIL it, right? 2 times the 4 gives us an 8. Pardon me. 2 times the negative 3i gives you negative 6i. 5i times 4 gives you the 20i. 5i times negative 3i would give you negative 15i squared. Right? It's literally what we've done before, isn't it? We just have the letter I instead of the letter X. But it's literally the same idea. Okay? So now let's see what we do when we simplify it. We would combine like terms in the middle, just like we did before. So we've got a minus 6i plus a 20i, so we get a plus 14i. Now, the only thing that's a little bit different is this last piece. Remember how we defined I? Pardon me. Your I is your square root of negative 1, right? That's how we define I, isn't it? When we square both sides, we get negative 1 for I squared, don't we? So over here where we have the I squared, pardon me, we'll replace that with negative 1. So this is the only part where it's different for multiplying complex numbers versus multiplying binomials with x's in them. Anytime you see an I squared, you'll replace it with a negative 1. Well, when you do negative 15 times negative 1, you get what? You just get a positive 15. And then we can add now the 8 and the 15 together and give us 23 plus 14i. Remember again, last time we talked about putting a complex number in standard form. Standard form said the real piece came first. So we would write the 23 first in this case. The imaginary part came second. So that's why we write the plus 14i on the end. That's standard form. And again, your answer is that you'll type it in Hawk, so that'll want you to put it in standard form. We'll do more examples of the multiplication, but is that okay? All right. Okay. All right, so let's do, like I said, for multiplication, that's literally what multiplication is. That's all you have to do. Okay? All right. So division is the only one that's a little bit stranger, but it's the same kind of thing that we did when we rationalized denominators back with radicals. Remember when we rationalized With radicals, we multiply by the conjugate for the denominator. We just change the sign in the middle. Okay? We're going to do the exact same thing here when you divide complex numbers. Literally the same thing you do when you rationalize denominators. I will multiply top and bottom by the conjugate of the bottom. Since it's with complex numbers, we call it the complex conjugate, but it's the same concept. When you do the complex conjugate, you change the sign on the imaginary piece. So since we had 4 plus 5i in the denominator, we multiply by 4 minus 5i. If it were 2 minus 3i, you would multiply by 2 plus 3i. You just put the sign on the imaginary part. Okay? Change the sign in the middle. All right. Now in these problems, we want to multiply out both the top and the bottom. Remember in those rationalizing ones, we didn't typically multiply out the top? We're actually going to multiply everything in this case. The reason why we're going to do that is because at the end, we want to write this in standard form. I can't write it in standard form unless I multiply out the numerator and I multiply out the denominator. So I need to multiply out both. Okay? So let's do the top first. And again, we're going to multiply this like we just did in the previous example. What do you get when you multiply out the top?
Minus 5i plus 12i minus 15i squared.
Good. Just like what we did with the polynomials, just like what we did in the previous problem, right? 1 times 4 gives you the 4. 1 times the negative 5i gives you the negative 5i. 3i times the 4 gives you the 12i. 3i times the negative 5i gives you the negative 15i squared. So far, so good? All right, what do you get when you multiply out the denominator?
16 minus 20i plus 21 minus 25i squared.
The 4 times the 4 gives you the 16. 4 times negative 5i gives you negative 20i. 5i times 4 gives you plus 20i. Positive 5i times negative 5i will give you minus 25i squared. What do you see happens in the middle in the denominator? They cancel out. Just like they do for rationalizing denominators, right? Remember we had the pieces in the middle that had the square roots and they cancel each other out? Right? Okay. So let's simplify this a little bit. Pardon me. When we combine the terms in the middle on the top, we've got minus 5i plus 12i, so we get a positive 7i. And then on the end there, again, what do we replace I squared with always? Negative 1. Every time you see an I squared, you replace it with negative 1. In the denominator, we have 16. The terms in the middle cancel. So we'll have, then we have a minus 25 times a negative 1. When we simplify our multiplication there, negative 15 times negative 1 makes a positive 15. Negative 25 times a negative 1 makes a positive 25. By the way, you'll know you're doing this right. In the denominator, all the i's should go away, and you should be adding both of these numbers together. You should not have a minus sign in here. It should always be a plus sign in the middle. Okay? If somewhere you have a minus left in the denominator, you multiplied something wrong somewhere. Okay? Should always be a plus. Now to finish this off, 4 plus 15 is 19. So we get 19 plus 7i on top. The denominator simplifies to 41. Now for me, this is a perfectly acceptable answer. There's nothing wrong with this. Hawks, though, I think, insists that you type things in standard form. And all that means is it wants you to split these into two separate fractions. Like that. So to put it in standard form, you would do your 19 over 41, and then plus the 7 over the 41 with the I on the end. Remember, standard form is number plus number times I. Okay, that's standard form. And I think Hawks insists on you typing in your final answers in standard form.
So you said this on the right is the standard.
The final thing on the right is the standard form. Yeah. Again, on an exam, on a quiz, this is fine with me, but Hawks is going to want it this way, if I remember correctly. We'll do more examples like this one, but is the process okay? All right. So then the last thing they talk about in this section is being able to calculate various powers of I. Keep raising I to higher and higher powers. Okay. Notice that there's a pattern, the whole point. Okay? It starts to repeat. So I to the first power, of course, is just I. Remember, when we have to the first power, we just don't write the power. And we've already discussed that when we do I squared, we get -1, right? Anytime we see an I squared, we have a -1. So let's look at, let's put these two things together and see if we can rewrite I to the third power. We'll notice that a third power, we can use our properties of exponents to write I to the third is the same thing as I squared times I to the first, right? Remember when you multiply, you add your exponents? So basically we're just doing that in reverse. We're writing 3 as 2 plus 1 and splitting it apart rather than combining it. Notice we can replace I squared with -1, and then -1 times I is just -I. Okay, look at the next one. I to the fourth. Well, 4 is the same thing as 2 plus 2. So we can break up I to the fourth as I squared times I squared. And what is each I squared equal to? -1. When we do -1 times -1, we get +1. So notice the pattern so far. We've got I, -1, -I, 1. Okay. So let's see about the next ones. Well, I to the fifth, we can write 5 as 4 plus 1. But what did we just say that I to the fourth was equal to? 1. And 1 times anything is itself, so 1 times I gives us I. Do the same thing for I to the sixth. 6 is 4 plus 2. So we have I to the fourth times I squared. I to the fourth again is 1. I squared is -1, so we get -1 again. We go through the same computations for I to the seventh. We end up at -I. Do the same computations for I to the eighth. We end up at 1. So notice it's the same pattern. I, -1, -I, 1. I, -1, -I, 1 every single time. So it repeats every 4. Okay? So here's how we can calculate powers of I pretty quickly. So let's look at I to the 26th. I look at my exponent, my 26. It repeats every 4. So what we're going to do is divide 26 and divide it by 4. It's going to repeat every 4. It cycles around every 4, so we'll divide it by 4 to start with. What we're interested in is the remainder. Okay? When you divide 26 by 4, you should get a 6 with a remainder of 2. Now, how do I know that quickly? Type it into your calculator. If you do 26 divided by 4 in your calculator, what do you get? 6, yeah, you get 6.5, right? The 0.5 represents your remainder. The 0.5 is not equal to the remainder. It represents the remainder. Okay? Like Trey said, it says a half, right? 0.5 is the same thing as a half. But what did we divide by? We divided by 4. The 0.5 represents a remainder of 2, because 2 over 4 is a half. Okay? So, if you get an even value, whole number, the remainder is 0. If you get 0.25, your remainder is 1. If you get 0.5, your remainder is 2. If you get 0.75, your remainder is 3. So you don't have to do long division to figure out the remainder. The remainder is represented by the decimal. If you don't have a decimal, 4 went into it evenly, so the remainder is 0. Okay? If you have a 0.25, the remainder is 1. A 0.5, the remainder is 2. 0.75, the remainder is 3. Okay? This has a remainder of 2. So what that tells me is that I to the 26th power is the same thing as I squared. It's the same as the remainder. Because remember, every time I raise I to the 4th power, what do I get? What is I to the 4th power equal to? 1. So if you do I to the 4th, I to the 8th, I to the 12th, 16th, 20th, 24th, counting up by 4s, I'm always going to get a 1. So once I get up to I to the 24th, I still have a 1. What's left over? I squared. And then what's I squared equal to? What do we say I squared is equal to always? -1. So we simplified it. Right? Let's look at this next one. That's on the back side here. It says I to the 15th power. Again, your first step is to do what with the 15? What do we do first with the 15? Divided by 4. Good. 15 divided by 4. Put that into your calculator. What does it give you? 3.75, right? What represents the remainder again? The 0.75, right? This part. So that tells you your remainder is 3. So I to the 15th must be I cubed. And what's I cubed the same thing as? Going back up to that list above. It's negative I, right? Because again, the pattern goes I, -1, negative I, 1. I, -1, negative I, 1. Okay. You want to do one more like that? I'm going to go more on the other worksheet, but we can do one more like that. Let's do a bigger one. Let's say I ask you for I to the 577th power. Again, use your calculator. First thing you do is what? Divide by 4. It's first step. Anytime you want to do I to a power and simplify it, first step is to divide it by 4. 577 divided by 4 equals what? 144.25? Is that what you said? Okay. What represents the remainder? The 0.25. That corresponds to a remainder of 1. So I to the 577th must be the same thing as I to what power? 1. And then I to the first power is just I. That's it for those. You can do it with your calculator, right? It's nice to be able to do that with your calculator. All right. So let's see if we can do a couple more examples here, and then I'll turn you loose on your worksheet. Okay, so we got a couple of multiplication problems here. For that second one, when I multiply the 4 minus 7i times the 3 plus 2i, what do you get? What do we get when we multiply those? Careful on the last one. I got to multiply.
14.
Yeah, negative 14 squared, right? Because I get I times the I. Okay. So then what do we replace the I squared with? Negative 1. So we get 12 plus 6i minus 14 times negative 1. So that last part becomes what? When we do negative 14 times the negative 1 there, we get plus 14. And so finally that goes 26 plus 6i. Does that make sense? We okay with that one? Okay. So the second one looks a little bit ugly, but it's not bad. We're going to multiply it like we did before. We do the 2 times the 5 gives you what? 10? 2 times negative 7 times negative square root of 7 times I gives you what? How do I write that when I do 2 times the square root of 7? I just write it as 2 times square root of 7, right? They don't both have a radical in them, so I don't need to multiply it together. I just have 2 times square root of 7 times I. What do you get when you do the next piece? Plus what? Yeah, 5 square root of 3i. And then finally, we do have both radicals in there for this one. So square root of 3 times square root of 7 gives you what? Square root of 21. I times I gives you I squared. Again, I squared is the same thing as -1. These don't have the same radical piece, so it's really hard to combine them, isn't it? Okay. What does this -1 do to the last piece? What does it do? Makes it positive, right? So we just get a plus square root of 21. So we get 10 minus 2 root 7i plus 5 root 3i plus square root of 21. Now notice that the directions tell you to write it in standard form. Remember, standard form is number plus number times I, right? So anything that doesn't have an I goes first. Everything that has an I goes second. And we have to do one little extra thing. I'll write it this way. If I want to write this in standard form, I need to factor off the I. Because remember, the standard form is number without the I plus number with the I. Okay. So to write it in standard form, for these two terms that have an I need to factor it off. That's the ugliest it'll get, I promise. Okay. But again, that's just a Hawks thing, by the way. It wants you to enter your final answer as a standard form. That's not a do it for me on a test thing. Yes.
I have a question on two. How did you get 6? Because I got 26 minus 13.
Because I forgot the 21. When I multiply, I forgot to write the 1. That's how I got a 6. I forgot the 1. You told me 21, and I just didn't write it. Yep, thanks. You're right. That's the minus 13. Sorry about that. Thank you. Yep. I just forgot to write the 1 and then didn't pay attention, so I just simplified it from there. Let's do the last one. When we want to divide by a complex number, what do you do first?
Change the sign.
Good. Yep. Change the sign, right? Multiply by the conjugate. Since we have 4 plus 3i in the denominator, we will multiply top and bottom by 4 minus 3i. And in this case, we want to multiply everything out. When you distribute the 5 through on top, what do you get? Good. When you multiply out the denominator, what do you get?
16 minus 12i plus 12i minus 9i squared.
Good. When we multiply, every time you multiply by the conjugate, the things in the middle should cancel out, right? So the minus 12i and the plus 12i go away here. What's I squared the same thing as? -1, which will change that sign to a plus, right? And remember, I said that should happen that way every time. Okay? So this becomes 20 plus 15i over 16 plus 9. You should have no i's left over in the denominator. And it always should be a plus sign in the middle. So you get 16 plus 9, so that gives me 25. Then again, for Hawks purposes, we should be able to split that up into standard form. So we get 20 over 25 plus 15 over 25 times I. Do those fractions reduce at all? Yeah, there's I can divide top and bottom by 5 in each of them, right? This one becomes 4/5, and this one becomes 3/5 I. Questions on that one? Yes.
How does the 20 minus 15i go from?
Oh, jeez, Louise. No, that's me. I just did it again. It's a minus sign. I was thinking about the plus sign in the denominator. That should be a minus sign on the top. Thank you. Other questions on that one? Sorry about the typo. Righto. All right. So go ahead and work on those. The other worksheet. I'll get answers posted. We'll also are going to do a quiz on Friday. Nothing new on Friday. We will review what we talked about yesterday or Monday and today, and we'll do a quiz over it at the end of the hour on Friday. Okay, so that's planned for Friday. All right, so I'll get answers posted up here, so you can see those as you're working.